Chapter 6.4, Prove Triangles Similar by AA. Okay, so the AA stands for angle-angle, and this is the angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. All right, so for the AA similarity postulate, you want to match two angles from one triangle to the other triangle. And what I mean by match is pick out congruent angles. So let's see. We see angle K matches angle Y because they both have the one mark right there. All right, so I'm just going to put a number 1 by that angle. And then we see that angle J matches or is congruent to angle X because it has the 2 marks. So I'm going to put a number 2 right there. All right, and when you make the similarity statement, you write the triangle symbol and then the 3 letters and then the similarity symbol, the triangle symbol again, and then the 3 letters. All right, that squiggly line, that just means similar. All right, so let's see. We have to trace both triangles the same way. If I go from angle 1, I'll go from the vertex point, from angle 1 to angle 2, and then the last letter. So that's going to be K, J, L. Okay, so the first triangle, I'm going to wrote it wrong there. I'm going to write K, J, L. K, J, L. And then on the other triangle, you want to trace it the same way. I went from 1 to 2 to the one with no mark. Same thing. I'm going to go from 1 to 2 to the one with no mark. So that's going to be Y, X, Z. Okay, that's Y, X, Z. Now, is this the only way to write it? No, definitely not. As long as it matches on both sides of the similarity symbol, it's fine, okay? If you want to write it the other way and write LJK, basically write it backwards than we did the first time, then you just do the same thing on the other side and write ZXY. All right, so there's more than one way to write the statement as long as it matches on both sides of the similar sign. Example 1, determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. All right, so the only method we learned so far is AA. So let's see if we can use that method to prove that the triangles are similar. And then we're going to write the similarity statement, just like we did a minute ago. So here's the 2 triangles. We need 2 angles, 2 pairs of angles that match. We have the right angles that match. So I'm going to label that angle 1 and angle 1, okay, because all right angles are congruent. And then we don't have the other angles, but we can easily solve for the third angle. So let's do that. This one right here. How would we solve for that? Well, we know the angles inside of a triangle. We know they add up to 180. All right, so if we just do 180 minus the other 2, so this one here is 90. It's going to be minus 90. And this one here is 64, minus 64. That's 90 minus 64. That's going to be 26. All right, so clearly 26 matches this angle of 26. All right, and I labeled this angle 1. So the other angle, that's 26. I'll do it in a different color. In fact, let me change the color here. I'll make that angle 1. And this angle here, that's 26. I'll make that angle 2. This angle here, that's 26. I will make that angle 2. All right, and now we have 2 angles that match. So we are in business. So if I were to write the similarity statement, I'm going to go from 1 to 2 and then the third angle. So I'm going to go G, K, H. All right, so that's going to be triangle G, K, H. And that is similar to this triangle. We went 1, 2. So here we're going to go 1, 2, 3. So that's D, C, E. Triangle D, C, E. And these are similar by AA. All right, because we proved 2 angles from one, match 2 angles from another one. Now, is this the only way to write it? No, you can certainly change the letters around. Okay, if you want to reverse the first and last, you can write the H first, and the K second, and the G last. And same thing here, you can write the E first, the C second, and the D last. So it's the same thing. All right, but these triangles are similar by AA because we matched 2 angles. All right, so example 2, show that the 2 triangles are similar. All right, so they probably want us to write the statement too, so I'm going to do that as well. All right, so we have a small triangle inside of a big triangle. And because both triangles, the small and the big, they both use angle A, I am going to mark that angle congruent to itself. All right, so I'm just going to put a mark on the angle A. And in fact, I am going to put a 1 right there. Let me fix that a little bit so it's more clear. All right, this is going to be angle 1. And now we can see the 52 matches the 52. So I don't have enough room to make 2 marks, or maybe I could. There you go, 2 marks. So I'm going to call that angle 2, and this 52 right here, make that 2 marks. I'm going to call that one angle 2 as well. Let me fix that. This 52 is also going to have 2 marks. All right, so angle A is in both triangles, and this angle matches this angle. So we could just make the statement. We already proved it. So triangle and similarity symbol and triangle. Let's trace them the same way. I'm going to go from 1 to 2 and then the third angle. So that's going to be A, B, E. Okay, so the first triangle is ABE. And then the same thing I'm going to do on the big triangle. I'm going to go A, C, D. Okay, I went from angle 1 to angle 2 and then the missing angle. So A, C, D. And those triangles are similar by AA. All you have to do is prove 2 angles. By the way, they gave us ABE and ACD. And if we didn't get the same thing, we can certainly rearrange the letters on one side, then do the same thing on the other side and try to match what they have. But again, you got to rearrange them the same way on this side and on this side as well. All right, part B, we have parallel lines here. All right, and what you do when you have parallel lines, you want to look for the Z shape. All right, so I can draw a Z with these parallel lines like that, and then like that. Okay, and the angles inside the Z are congruent because those are alternate interiors. So I'm going to mark this angle here congruent to that angle there. It is the angles inside of the Z. All right, what else can I mark? Well, when you have an X shape like this, those are called vertical angles. So I can mark this one here and this one here. All right, so those two match. And let's put in the numbers as we did before. This one here has 1 mark. This one here has 1 mark. And these both have 2 marks. So that's it. We just proved it. Triangle, similar, triangle. Let's see. I'm going to start at 1 and then go to 2 and then go to the missing one. So I'm going to go S, V, R. Okay, I went from 1 to 2 to the missing one. S, V, R. And then on the other side, I'm going to go 1 to 2. U, V, T. U, V, T. Okay, it matches what they had. If not, you could mess with it and maybe reverse the letters and see what happens. But we got it on the first try, so these triangles are similar by AA, angle, angle. All right, guided practice, show that the triangles are similar and write a similarity statement. All right, please pause and try number 1. This one is strange. We don't have angles that match from one triangle to the other. However, if these 3 angles are congruent, and we know the interior angles of a triangle add up to 180, we know that each angle is just going to be 180 divided by 3. And that's 60 degrees. Okay, so all of these angles are 60 degrees. And the same thing here. If that's 180, all of these angles are going to be 60 degrees as well. So these angles in both triangles are going to be 60 degrees each. So these 3 match these 3, and really it's pretty easy from there. All right, they said FGH, and that's going to match RQS. So let's make sure the first letter matches. Does F match R? Let's see. I'm going to put a 1 on the F and a 1 on the R. Well, we said these were 60 degrees each. So yes, this one definitely matches that one. And then the second letter is G and the second letter is Q. So I'm going to put a 2 there and a 2 there. Do these match? Yes. They're all 60 degrees each. So they all match. So we can say F, G, H, and they already did that. And we can say R, Q, S, and they already did that. All right, so F, G, H matches R, Q, S by AA. Now, again, this one is strange because I said if you reverse the letters on this side, you have to do the same thing on this side. But for this problem, you don't have to do that because they are all congruent. All of these are 60 and all of these are 60. So if I said HFG, and I just left this one alone as RQS, it actually still works. And that's because each one of these are 60 and each one of these are 60. These are equilateral, equiangular triangles. So you can change one side without the other in just this special case. All right, please try number 2, and I suggest you solve for the missing angle. All right, on the bottom here we have a right angle, and this on the bottom is straight, so I can make another right angle right next to it. All right, so this right angle matches this right angle. I'm going to make it angle 1 on each one. And this one here, let's solve for this. Okay, inside of a triangle, it adds up to 180. So this one here, that's going to be 180 minus 90 minus 32. All right, and that is going to equal 58. So that 58 is going to match this 58 right here. All right, as a result, I'm going to label this 58 number 2, and this 58 here is also number 2. All right, now I'm going to trace both triangles the same way. So the one on the left is similar to the one on the right, but let's do the 3 letters. I'm going to go 1, 2, and then the third angle. So right here, it's going to be F, and then D, and then C. All right, so that's going to be F, D, C. I didn't make the triangle symbol, but that's okay. And the one on the right, I'm going to go 1, 2, 3. F, E, D. F, E, D. Now, does it match what they have? No, but we can reverse the first and last. We can make it C, D, F. And then we can make it D, E, F. And that's what they have. And those are similar by AA. Angle, angle. Okay, example 3. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? All right, we're going to draw a diagram in the form of 2 triangles. But notice, of course, that the woman is standing straight up and down, and her shadow is going left, right. And the flagpole is standing straight up and down, and its shadow is also going left, right. So when I draw my diagram, I am going to make a right angle between the woman and the ground, and I'm also going to make a right angle between the flagpole and the ground. Okay, and once we prove 2 angles congruent, all we have to do is prove 2 others, and we know the triangles are similar. So let's make a diagram of these 2 figures here. All right, so here are the 2 triangles, and on the bottom is the length of the shadow. Okay, so I'm just going to write shadow on the bottom of each triangle. And this right here is the height of the woman. And X is the height of the flagpole because we don't know it yet. All right. So this triangle is for the woman. This triangle is for the flagpole. And you have to imagine in the background, far, far away, that the sun is shining in the background, far, far away. And as a result, the sun's ray projects onto the woman at the same angle that the sun's ray projects onto the flagpole. So as a result, this angle is going to be congruent to this angle right here. Okay? Because the sun is very far away, and it's basically making the same angle with the ray on both the woman and the flagpole. All right? So as you can see from the triangles, the right angles match, and these angles match here as well. So these triangles are similar by AA. Okay, we don't need to write the similarity statement. We don't even have vertices on the triangles, but we can label the angles. Okay, I'm going to label the right angle 1, and I'm going to label the angle with the sun's ray. I'm going to label that 2 in both of the triangles. And then if you want, I think it would help if you labeled the third angle 3 on each triangle. And why is that? Well, if two angles from one triangle match two angles from another, the third angles are also going to match. All right, and now we can set up the ratio and proportion. All right, we're going to have two fractions here. I'll do it in a different color. We're going to have two fractions. And one fraction, or I should say the numerators, are going to be for the woman. And the denominators are going to be for the flagpole. Okay. Now what you want to do is go across from the same angle on each triangle. So I see the side length of 40 here. That is across from angle 2. All right. And this triangle was for the woman. And this triangle was for the pole. The flagpole. All right, so across from angle 2, we have this side length here. That's 40 inches. So I'm going to label this fraction angle 2. And the one for the woman across from angle 2, that's 40 inches. Now, on the other triangle across from angle 2, you have this side length here. That's 50 feet. All right, so the numerators for the woman, the denominators for the pole. And now look at the other side length given. Okay, across from angle 3, we have 5 feet 4 inches. So I'm going to label this fraction 3. And the one for the woman across from angle 3, that's 5 feet 4 inches. Now, see, this is in inches right here. I don't want to mix feet and inches. So let's make it just plain old inches. How many inches are in a foot? 12. So how many inches are in 5 feet? It's going to be 5 times 12 plus the 4 inches, right? 5 feet is 5 times 12 inches plus 4. That's going to be 60 plus 4, or 64 inches. All right, so the height of the woman is 64 inches. And finally, we went across from angle 3. You go to across from angle 3 right here. The height of the flagpole is X feet. Now, do you need to do all this? Not necessarily. I am just explaining it to you, okay? You can certainly do X divided by 50 equals 64 divided by 40. If you want to do it that way, that's fine. All right, cross multiply. Top times bottom is going to be 40 times X. And I'm just going to include the units just to show you that they're going to cancel. 40 inches times X feet. All right, I'll just include them for now. And that equals bottom times top, 50 feet times 64 inches. All right, solving for X. The opposite of times 40 is divided by 40. All right, 40 inches divided by 40 inches cancel. Inches divided by inches cancel. And you can cancel units or just do this whole thing on the calculator and you'd get X. All right, so I'm going to do 50 times 64 divided by 40. And I get X equals 80 feet. And that is answer choice C, 80 feet. All right, let's try example guided practice number 4. It says a child who is 58 inches tall is standing next to the woman in example 3. How long is the child's shadow? Okay, let's set up the triangles with the child being 58 inches tall, standing next to the woman. All right, so we have the same setup here. The two triangles are similar by AA, and we have the woman on this triangle, and on this triangle will be the child. All right, And nothing changed for the woman. Okay, but the child's height, instead of the flagpole, we're going to put in the child's height. They said 58 inches. And they want to know the length of the shadow. So I'm going to make that X. Since the woman's shadow is in inches, I am going to make the child's shadow in inches as well. All right, so same triangles, basically, except really this one should be smaller, but it's just a diagram. It's not drawn to scale. Anyhow, the dimensions for the woman's height and shadow remain unchanged, but you have to fill in the height and shadow for the child. So please do that, cross multiply, and then solve. All right, so look at the triangle for the child. This fraction is for angle 2, and for the child, triangle, go across from angle 2 right there, and you can see that is X inches. All right, and then across from angle 3 is this fraction. The denominator is for the child, so across from angle 3 on the child triangle, across from angle 3, we have this side length here, that's 58 inches. All right, in case you don't realize, I'm going from angle to side length, angle to side length. All right, and now we're in business. We can just cross multiply, and really all the units match. So we're good there. Top times bottom is going to be 40 times 58. All right, I'm not even going to write the units because they all match. They're all going to cancel. Bottom times top is going to be X times 64. All right, the opposite of times 64 is divided by 64. You do that to both sides in order to solve for X. Cancels right here. I'm going to do this part on the calculator. If you want to do this by hand, I would cancel, reduce top and bottom. But I'm going to do 40 times 58 divided by 64. And I get 36.25. The units on the shadow were in inches. So X is going to be 36.25 inches. All right, again, I realize that you don't necessarily have to do it that complicated. You could just do 58 over X equals 64 over 40. But I labeled everything because some of the triangles are going to be different and you may need to label them.